we are going now to begin our webinar dedicated to flexibility. Welcome to all of you. We will be many people today participating to this meeting. So thank you to be here with us to share these different insights about flexibility. My name is Valériane Langsnar, and I am the managing director of Smartgrids, the association that has been organizing this webinar alongside CIRED France and SEE. Please, could you, the people who did not disconnect their microphone, please do so in order that we can hear very well all the different speakers. So, for example, now I am hearing some sound. Thank you very much. So I must say to you that this webinar is registered, and that we are going to send you all the slides at the end of the meeting. So don't worry, you will obtain the slides. So Smartgrids in France represents about 10% of the global market share in the world, which is valued to more or less 100 billion euros. And in France, we are also investing about 100 million euros a year in R&D. I'll be very short, just to show you who we are. Sorry, the next slide is here. So our members are, among them, Enedis, because Mrs. Legnaud, who is the chair of Enedis, is also the president of our association. We also have, alongside our members, RTE and many other companies like EF, but also Schneider Electric, GE, Siemens, Atos, and so on and so forth. Two observer members, the Regulation Commission, and also the French state through the Ministry for the Energy Transition and the Ministry of Economy. You can see also that alongside our members, we have many small companies, SMEs, startups, schools, universities. So all our members are about 100 organizations, very different, and working on different topics. So what are we going to tell to you today? Our goal is to talk to you about flexibility and the state of art of flexibility. So with the development of the renewable energies, with the development also of the electrical mobility, we believe that flexibility is a topic that is going more and more important. And that's why you are so numerous today to follow us on this webinar. First of all, Mr. Malo from Schneider Electric, who is also teacher at the University of Grenoble, will give us some light about the definitions of flexibility. Then Mr. Verhaeghe from the French regulator will go a little bit deeper on the regulation and the market model. Then we will have the pleasure to welcome Mr. Dupin from Enedis. He's the head of the flexibility. Enedis is the biggest DSO in France. Then we will have the pleasure to welcome Mr. Cantegrel from Energy Pool, who will detail us his experience in Japan, introducing some flexibility with TEPCO. And the last speaker will be Linia Rees from NG Green, from the R&D direction, giving us some explanation with Mrs. Joss from ESPUL about one demo project about flexibility. And Mr. Jacques Mar from RTE will conclude. So I will stop now and will give the word to Pierre Mallet. Pierre Mallet is, you are, Pierre, the Research and Development Director, but also in charge of innovation at Enedis, the main French DSO. Pierre, the word is yours. The floor is yours.
Thank you, Valériane. Good morning, everybody. My name is Pierre Mallet, as Valériane said. I am Director for R&D and Innovation in Enedis, but I am here speaking as a chairman of the French National Committee of CIRED, and I'm also a chairman of the Technical Committee of CIRED. CIRED is very pleased to be one of the co-organizers of this webinar. I will say a few words to present CIRED. CIRED is the leading forum where the power distribution community meets. The power distribution community includes network operators, but also component manufacturers, solution providers, academics, research centers, and also regulators. It's a true worldwide organization with members all over the world. We have indeed about 24 national committees and also liaison committees who are active and part of the organization. We organize conferences and workshops. The next ones will be, we will have a major conference in Geneva this year, and next year we will have a workshop in Shanghai. We also manage a number of working groups on the high-stakes issues related to power distribution. So CIRED is very pleased to co-organize this webinar on flexibility, which is really a very important topic for the future of power systems. I won't be longer, I think François will say a few words, François Gerin from SEE.
Thank you, Pierre. So I am François Gerin, the chairman of the SEE, Society of Electricity and Electronics, a French scientific association, which is a meeting point of industry, power operators, labs, and higher education. Through its technical clubs, SEE is highly involved into energy and particularly electric power systems.
François, sorry, can you close your video because the sound is really bad. So maybe it will help to hear you a little bit more. François, we do not hear you anymore now. Can you put your mic on, please? Yes, please go on.
So I was just explaining that SEE is highly involved into energy and particularly electrical power systems, including the last developments of network flexibility. And we are proud to contribute to this webinar, which is in line with former papers published in our magazine, the Revue de l'électricité et de l'électronique, which is issued 5 times a year. Thank you very much for your attention. I give now the floor back to Valériane.
Yes, thank you, François. So now we will begin our webinar right now with Alain Malot. So Alain, you are a practitioner from the power system. You've been working at Schneider Electric for many years now, and you are also teaching this topic at INP School, University. It's the University of Grenoble. So Alain, the floor is yours. We cannot hear you, Alain. So maybe you are on mute.
Unmute. Perfect. Can you see my screen?
I can see your screen and I can hear you. Go on.
Perfect. Let's start on time. I'll make sure I stick within the 15 minutes. Do let me know if I extend. So thank you for the introduction, and just to remind that I'm here on behalf of the university on the invitation of Professor Noureddin Haj-Said, who is the CTO of the association, and I'm part of his team in the university. Let's go into defining flexibility and see what words are behind this concept. And I will start by a publication by International Smart Grid Action Network, where you can see that based on different viewpoints across different organizations in Europe, in world level, IEA and EPRI, people use different terms to define flexibility. So there's currently no alignment, and it deserves some attention to look at the concept and what it means exactly. What is sure is on the top, we have something which flexibility as a term is used as an umbrella covering many aspects, and which today do not converge in a single set of definitions. If we refine this definition, we find two different aspects, which is flexibility from grid customers on the one hand, which is the first bullet paragraph of this summary, and the second part is about flexibility from grid assets. About grid customers, we are talking about end users and producers connected to the grid, which provide implicit or explicit flexibility as per the European term. And this comes with the form of monetized services. So the flexibility itself is the ability to quickly provide upward and downward power adjustment on one or multiple sites with a given time framework and a response to an external signal and to deliver a service. It's not only technical, markets do play an important role. We will see that. It's also economical, and it's not only real time, it's across multiple time horizons. So it's something which is viewed as a very strong enabler to defer capital expenditure in the wake of a massive integration of distributed energy resources. There are two forms of monetization. One is linked to the retail price, which is a price signal, which is implicit, and the other part, which is a contract outside the price so the retail contract, which is called explicit. And there are some initial thinking on how also activate a CO2 signal in the way people react to low carbon signals coming from the grid. When we say power adjustment, it's mainly about active power, but some markets do also value reactive power as a side product of the flexibility. The newer aspects in some countries, France was one of them, is not the only one, is also to go to behavioral demand response where there is no monetization. And it's a very actual thing since it's been activated in France last week during the cold snap. People are invited to respond to signals coming on the social media, on general press, or on social networks, to refrain from using electricity during peaks. And this is something which is not valued as monetization, but does give excellent response in terms of ability to curtail part of the load during peak events. The second part that we also see from the testimonials from RTE is about using grid assets, so doing active network management, not using the grid customer flexibility through monitoring and control of the grid, and advanced technologies, and the most talked about one being the grid assets in the form of batteries, which may or may not be allowed by regulation depending on countries. Vocabulary itself is kind of a problem. So you can see here some variations of the term flexibility in the demand side parameter in English and in French language. Depending on where you are in Europe and the US, you might use some flavors of the different pieces on the top side, demand response, or in the UK demand side, or in the US demand flexibility itself. There's no alignment and an ongoing use of different terms, and the same applies to the French language, where some of us do use the English word demand response. Some other communities used from flexibility down to modulation as terms applicable to the way to define demand-side flexibility. In Europe, this is aligned to be DSF, demand-side flexibility, which is the term that I'm using most preferably in my speech. What are the reasons and the trends on flexibility? So I'm very happy to see that we have Mr. Manuel Sánchez Jiménez himself on the call, which is a great honor for me to quote him with this very famous chart, which is simplistic enough to be produced through policymakers and the Brussels level commissioners, which is a low-level communication. And I fully appreciate this, reflecting the trends on the left-hand side, moving from a centralized system to a decentralized one, moving from conventional to renewable, and going to a fixed load pattern, so it's something which is much more variable, typically the EVs as being major trends in the power system transformation. The obstacles seen, as we know, are both congestion and instability on the technical point, but there is just important enough topic on volatile markets where we see some peak prices and some negative prices and some problems with valuation of energy and capacity in the markets in the current migration from traditional resources to renewable resources. So markets is also a big topic, which leads on solutions which are a combination of technical solutions known as smart grids, which we all know of, and also just as important reshuffle of intelligent markets on a national level and in Europe in a pan-European level to create single electricity markets. And the keys to enable that is the magic word flexibility, which is tied to both aspects, the technical and the economical one, where we will see a depiction of the value streams attached to that. This value stream here is applicable to the French mainland landscape, with the top layer being a separation between transmission, markets, and distribution, as you can see here, with RTE being the transmission network system operator, TSO, and Enedis being the DSO. As per the market unbundling in Europe, we have this kind of fragmentation, which is region specific. So in other places in the world, this might be totally vertically integrated or having some other forms of value chain arrangement as in the US. So I'm just representing here what is applicable to France and most of the European markets as definition of those three boxes on the top. On the bottom side, we can see what I just talked about being the supply side flexibility, so the grid-connected generation assets, which can be traditional or renewable. I can see on the load side, the end use, which is made out of the traditional commercial, residential, and industrial sectors. Also extending into new types of loads contributing to the flexibility, which are the electrolyzers of the power to gas, which are likely to pick up very fast and being a very interesting source of flexibility in the coming future, as well as data centers, who show up to be also a great contributor to flexibility. And when we talk flexible assets, we have three categories in play, which are power generation, energy storage, and flexible load. So this is the top layer and the bottom layer, and in between are facilitation layers, which we can see here. And the two main stakeholders are the retailer and the aggregator. The aggregator, where we will have the testimonial of Energy Pool later on, is in charge of bundling or pooling generation and load assets to value the services to the different participants, originally to the TSO, but also in the future with DSOs, as well as attached to the market role with market participants, while the retailer is in charge of doing the monetization of flexibility through price signals, so dynamic price signals being simple time of use or dynamic pricing, with potentially the application of hourly pricing in some countries to really reveal a high level of flexibility with high price variations on the wholesale. And the referee, the orchestrator to this complex value stream, which involves many, many different players, is the regulator. So in French, the CRE, Commission de Régulation de l'Énergie. So our next speaker will explain what is the trend towards organizing this play, regulating, producing network codes, and making sure that the rules of the game are fair and enable a greater use of flexibility. The quote on the left summarizes the fact that flexibility enables to run closer to the technical limits and while maintaining security of supply. The risk of wrong manipulation of flexibility might lead to unbalance on the networks and might causes blackouts if not properly orchestrated. And it's about capex optimization gains, which in some recent studies, as I will mention, are quoted as being in the region of multi-billion euros in the wake of the system transformation. So quite big financial stake attached to the flexibility. Just to put some data points and some interesting publications for your review, if you want to know more, International Energy Agency has produced a web page, which is on the bottom here, on demand response trends, and reflecting the fact that North America has traditionally been more advanced. Europe has got a very uneven level of implementation of flexibility. France is being quite advanced in that space, and Asia Pacific is just building some new markets. The second point is an excellent paper from Energy Pool on the way to implement demand response in regulated markets, which is a specific tricky situations based on the lack of deregulated players, especially for aggregators. So it's a subset of the conversation, which is so much interesting in terms of organization. The second publication, which is of interest, is coming from the European Association Smart Energy Networks, which is about demand response players bundling and promoting the greater use of flexibility. And in this very recent report, you can see the real status across 10 countries in terms of maturity, in terms of barriers and non-discriminatory participation of stakeholders. And as you can see from the colors on the left, France has got quite advanced policy and regulation approach to demand side flexibility, which dates back from 10 years and which is also being adapted in the wake of a future greater demand for flexibility on demand side. Just to conclude on a media publication from Le Monde de l'Énergie, a French media, which has put some perspective on the value creation and fully linking the energy transition stakes, which are about renewable integration and decentralization, as we said. And is it about a gold rush about to happen in the wake of this transformation, which is still an open question. We can see the landscape is very dynamic. The new players are there. The barriers on regulation are still there and needs to be removed. So there was a conference yesterday organized by Electriques and ETSO, and it was a big part of the conversation. So we are likely to see a very hot and lively debate, both at European level, at member state, and also beyond across the world. That's the end of my presentation on time, and I give it back to you, Valériane.
Thank you very much, Alain, for this presentation, giving us the global frame for flexibility. So answering to some questions, yes, this webinar is recorded, and yes, you will obtain the slides will be provided to you at the end of the webinar. If you have questions to the different speakers, please do not hesitate to write them in the conversation yes, point. And then at the end of our webinar, Mr. Gerin will ask these different questions, trying to summarize them to the different speakers. So please be patient. You will have your answer at the end of the webinar. And now I will give the word to Charles Verhaeghe. So Charles Verhaeghe is head of the transmission of the electricity section at the French regulator, the Energy Regulation Commission. So Mr. Verhaeghe, the floor is yours.
Good morning, everyone. Thank you for the invitation. And first of all, also best wishes to everybody. I'm going to try to share my my slides. Can you see it on your screen?
Yes, we do.
Great. So the goal of my presentation today is to give you a brief overview of the regulatory framework and market design for flexibility in general in France. So the idea is really to give some highlights on what we've done so far in order to promote flexibility participation in markets in France today, and what are the next steps for us in order to try to improve even further the regulatory framework and design. Just to begin with, and not to say what Anna already explained it quite clearly, flexibility sources is not something brand new. It started a couple of decades ago in France. For instance, there is a demand response through tariffs since the 80s. There is flexibility from generation or from pumping storage also for decades, but there is new needs in the system, new technologies that can provide flexibility. And here you have also illustration. For instance, the smart meters give more tools for consumers to participate in market and provide their flexibility. Electric vehicles will also will be able to provide flexibility, battery storage, and also renewables. Renewables can be both the trigger for the need for new flexibility, but it is also a source of flexibility that can provide value to the system. And I'll come back to that with a good example afterwards. As Alain said, through the reference to Spartan papers, in France, we are quite advanced in terms of flexibility regulatory framework. All market segments are now open to flexibility providers, including storage, including demand response, including flexibility sources that can be aggregated throughout the distribution networks. Here you have some examples of what we've done in terms of capacity provision, in terms of energy provision, both in the balancing and in the wholesale markets. Just to give you a few figures to illustrate that, for instance, demand response is contributing to up to 20% of balancing reserve, ancillary services, and tertiary control. So it's more than 500 megawatts of reserve, which is provided by demand. You have also emerging battery storage, contributing to the provision of reserve, 23 megawatts in 2020. So it's developing alongside with the building of new batteries in France. Demand response also provide capacity in the capacity mechanism. So in France, we have a capacity mechanisms which targets to ensure you have sufficient capacity to meet peak demand. And to do so, demand side response capacity is also contributing to that. Up to 2.6 gigawatts of capacity is provided by demand response aggregators over the 90 gigawatts of capacity to be provided in the market. Regarding energy, at this stage, the volumes are quite limited. You have about 10 gigawatt hours of energy provided by demand side response in the balancing market. You have maybe twice as much in the wholesale market through the NEBEF mechanism, but you have also flexibility provided through tariff. And in terms of design, it allows aggregators, demand side response, storage operators to participate, maybe not all the time because the value is not there, but to participate in critical moments where there is need for this flexibility. And also what's interesting with this NEBEF mechanism, which is quite particular and complicated, I won't give you the detail now, but it allows for the participation of independent aggregators. So the consumers directly can provide its flexibility, but also an aggregator, which is different from the consumer and which is different from the electricity supplier. In terms of capacity, flexibility, capacity development, through the capacity mechanisms, which was implemented in France in 2017, we've seen the developments of demand response. So this mechanism is aiming to contribute to security of supply. When the Commission approved this mechanism, they requested France to implement also a mechanisms to allow for long-term contracting in order to foster the developments of new capacities. And the outcome of this mechanism, which was introduced in 2019, is that in the end, the new investment which was triggered by these mechanisms is solely flexible assets, namely storage capacity and demand response. So for instance, in the last auctions, there was 250 megawatts of new storage capacity and 125 megawatts of DSR capacity, which are expected to be commissioned this year and next year. And last, in terms of capacity provision, again, the Programmation Pluriannuelle de l'Énergie, which is the planning exercise of the government in order to define generation mix and energy policies in the medium to long term, also set objectives for the developments of demand response in France. And to meet this objective, we've organized a tender for demand response. We organized it every year, so RT is organizing this tender. And you can see that there's a strong development of demand response over the years. We've now reached 1.5 gigawatts of demand response. And also a change throughout the time is that initially within the demand response, you had half of what we call green demand response, so pure demand response, and half of it was actually basically fuel dispatching tools that could actually ensure that demand can be maintained within a consumption site without withdrawing electricity from the network. But these assets were actually quite polluting. And so now gradually what you can see is that we've replaced this gray demand response by actually all green demand response. To continue, we still have many improvements expected in the future in order to facilitate flexibility participation. I won't go into the details, but basically we're trying to be more market-based to make sure that all the detail rules for participation are adapted not only to form of flexibility sources, but also new storage capacity, renewables, demand response. And now I think the main field of work that we are carrying on with the system operators is trying to develop flexibility as a service for network congestion management. Flexibility has played a role also in network congestion management for many years. Network tariffs provide signals to avoid congestions overall within the whole system, but also locally. And RT also uses redispatching through the balancing market to manage congestion. It was mostly conventional generators, but now it's opening to any forms of flexibility. But what we're trying to do is to make sure that we can actually use more flexibility in order to smoothen the energy transition and make it as ambitious as possible, while ensuring a secure operation of the system and minimizing costs for network users. So just to give you some examples, and I think Enedis will come back to some of them into more details as regard distribution. But for instance, it is providing flexible connection, which allows to optimize the connection needs especially for renewables, and therefore reduce connection costs for them. It includes optimal development strategy used by Enedis ORT, which will be explained to detail as for the transmission in the next slide, and also tendering flexibility resources to manage congestion. And through these mechanisms, we can avoid building new lines if the use of flexibility is cheaper or more efficient. Just to explain to a bit more detail the logic of the optimal developments of the network. The idea is really to maximize the possibility of renewable integration in the system while trying to minimize the costs. And we've actually looked at this strategy last year, and we've validated the strategy of RT. The idea is just to not to design the network in order to meet the maximum power that can be generated in renewables assets, but to dimension the network in order to be as efficient as possible, allowing for limited generation curtailment when there is strong wind or high sun exposure. These generation curtailments are very limited. The expectation is that through this approach, they might be up to, as a maximum, up to 0.3% of generation curtailed in 2035, but this will save up to 7 billion of investments in the system. So it's a very cost-efficient way to dimension the system. And what is foreseen at this stage is that the renewables which will be curtailed through this mechanism will be compensated, so that there is no impact for them on their investment. The last example, and I will finish my presentation on this, is the tendering of flexibility resources to avoid investments. The resulting to flexibility resources is something which is possible. We've allowed an experimental project using batteries. It's called the Rengo project. So basically, RT is building 3 batteries in its transmission system in order to manage congestion, and also using them in order to avoid any interactions with the market, in order to not to create any bias. But the fact that system operator owns a battery is actually something which is not directly allowed by the European law now, since 2019. It's only allowed as a derogation under certain conditions. So that's why here we've only allowed for an experimental project, and after 3 years of experiment, the battery will be sold to other investors. Also, in order to try to generalize this approach as part of RT's investment strategy, we have requested RT to establish a framework to allow flexibility sources to be contracted instead of building new lines. and RT has developed this roadmap, which is starting now very concretely by launching a call for interest in 4 zones in France in order to see whether flexibility sources could be developed there in order to answer network needs. If this call for interest is successful, there will be tenders and contracting, and therefore flexibility resources would be used in order to avoid congestion and investments in the long term. So throughout all these measures, we are trying as much as possible to grasp all the value of flexibility in order to facilitate the energy transition while keeping costs down, while also avoiding unnecessary investments in networks which also face acceptability issue and so on. So this is why also we think flexibility is a key for our energy transition. Thank you very much.
Thank you, Mr. Verhagen, from the French regulator, to have given us this about what is the global regulatory frame in France. Now we will give you some examples about how this flexibility is taking place with the DSO, with our distribution system operator Enedis. This is the main DSO in France. So Mr. Hubert Dupin, you are head of the flexibility department at Enedis, and you will provide us some examples about how do you make this flexibility happen in France today. The floor is yours.
Hello, good morning, everyone. So indeed, I'm head of the flexibility department, and my mission is quite simple to state, is to make flexibility normal business in all our processes, information systems, and business units within a few years from now. Okay, so as previous presentations have shown, France offers already a favorable environment to value flexibilities. So far, flexibilities have been handled on national mechanisms. As a result, there are many sites connected on Enedis network, about 40,000 flexible sites that are active on national mechanisms. 40,000 flexible sites, that's about 100 times more than there are sites on the TSO, meaning that we have quite mature process to handle those flexibilities. What's new now is for the DSO, that is Enedis, to make use of those flexibilities to help manage and design the distribution network. So we started a few years from now with technical demonstrators. It's a quite an obvious test and learn approach. Those technical demonstrators aimed at defining the technical or assessing technical and economical aspects of flexibilities. In 2017, we started with real-life experiments, meaning that we used flexibilities to solve real constraints, and there were actually real contracts with stakeholders, with money involved. So in 2017, we started with our first experimental flexible connection for producers. So people name flexible connections, smart connections, or conditional connections. All are the same. Basically, that's for producers or a customer. We can, so far, the regulatory framework is to connect any customer with the capacity they request, and such customer can make use of that capacity anytime without constraints. That's the current framework. Now with flexible connections, as you know, the economical optimum is different. We kind of look with the customer what is its actual need for capacity, at which time of year it occurs, And sometimes we can make a better optimum, that is kind of avoid unnecessary work that would be induced with those capacity usage disposition, but that the customer will make no use. So we designed the connection with less work, meaning that the connection is cheaper and sometimes faster. So for producers, we started those experiments, and as a result, we kind of assessed that for producers, the collective value savings may be in order of 90 kilo euros per megawatt. So it's quite a significant savings. In 2018, we started experimental flexible connection for consumers. Savings is about the same. And in 2019, for winter 2018-2019, we started. We contracted the first over-the-counter contract to solve congestion on the network. As a result of those experiments, we are ready to industrialize flex connection for producers this year, at the end of this year. Of course, we need regulatory approval and evolution of the legal framework, but particularly we are ready to propose such connections to producers. And so that's for bilateral contracts. Now, when it comes to contracting flexibility services, to contract market-based flexibility services, we did the first call for tender last year, so it was in summer last year. We had our first real-life tender for local flex, and at the end of the tender, we signed the first 2 contracts for DSO on to solve real constraints. So we're quite happy of that signature and that step forward. Doing so, we anticipated the so-called clean energy package, which is energy market directive. And well, there are 2 ways of looking at this contracting. We did tenders on 5 zones, and there were only 2 offers and 2 contracts that we could sign. So just a bit of step back. When we talk about market-based flexibility, and when we call on developing markets of flexibility, one has to understand that it's kind of theoretical, but it's a sound reality. Market is a meeting of demand and offer. So as a DSO, Enedis commits to analyze grid constraints, and we publish flexibility opportunities. Where do we need flexibility? When do we need them? How much do we need? And that's, in a sense, our demand. And now the offer of flexibility services is provided by aggregators mainly. And they have to recruit sites to provide the reliable flex services. And of course, contract is when demand matches offer in prices and specs. And I have seen a few questions in the conversation line. One has to remember that for us, flexibility is a way to find a better optimum in terms of cost efficacy than already existing levels, which means 2 things. First, flexibility scarcity does not induce high prices for flexibility, or another way to see it is that if flexibility prices shoot up, then we will go to traditional levels. So there is a maximum price on flexibility. Second thing is that for us, we do need to provide a reliable service to our customer. So when we go to flexibility services, we need a reliable service, meaning that if the service is not reliable, then it has basically no value for us, and we will go back to, and we will be forced to use traditional solutions. So we started our tenders for consumption constraints, so there was too much consumption. So like we say, we are technology neutral, meaning that to solve a congestion because of too much consumption, we can either reduce consumption or have more injection on that local loop. So those were the tenders that we started in 2020. And this year, we will have tenders to optimize hosting of renewables, meaning that we have in those areas too much injection. So the solution will be reversed, reducing injection or having consumption, more consumption at the time of injection peaks. So indeed, our main value for flexibility is to optimize connection of renewables. Basically, so far, as I said, the regulatory framework to connect renewables is to consider and to give them capacity to inject full capacity at any time. Now, when you look at the load duration curve of renewable, you can see that it's not a flat curve. In essence, for photovoltaic renewable, it's quite steep. So if we were allowed to use flexibility, that is to curtail production, we can indeed target a better optimum. We can target a better optimum by technology, being solar or wind. And also we can figure out that solar installations and wind installation do not produce at full capacity at the same time. When we do that, we did an assessment in 2019 with UFE, the French Union of Companies for Electricity. And the middle map, the map in the middle of the slide shows how much more renewables we can connect on a single transformer when we can make use of flexibility. So say in the southwest of France, we can connect up to 50% more renewables than that is allowed with the current regulatory framework. As a result of that design, we could save 30%. We could have 30% savings on the cost of substations to connect renewables. And of course, it comes at the cost of the curtailment. So we have 300 million euros savings on CapEx at a cost of about 50 million euros production curtailment. The net cost, the net saving is 250 million euros. Now, when we think about curtailment is very marginal. It's less than 0.06% of average production curtailment, which is very, very little. So we will start an experimental in the southwest of France, in Nantes, and which is mainly solar. In the north of France, in Somme, which is mainly wind farms. And in 2024, we hope to have collected enough feedback to justify regulatory evolution so that we can put that in our normal business. Now, inserting flexibility in our industrial processes and in our ecosystem is not only a matter of designing the network. Of course, it's a matter of designing the network, but it's mainly it's a tool that we have to handle in real-time operation. Like I said before, flexibility value is catched when we activate just a proper amount of flex in real time. So that's real time and reliability in real time that saves money. So there is a specific work package to insert flexibility into grid operation. Now, like we showed, there are many existing national mechanisms to value flex. So of course, we have to coordinate with those national mechanisms. Fourth work package is indeed to work for market design, to go with our stakeholders to build a framework of rules and processes. The fifth work package is sometimes also not enough known, is that so far for a network operator, all our assets are basically put into our processes, into information system as a static object, meaning that you build a cable, you put a transformer into operation, and all those parameters are basically for their entire lifetime into our information system and processes. When you go to a flexibility service, well, you have this kind of virtual assets, if we could make this parallel, which will be there, say, only on weekdays in February and January from noon to 2 p.m. And the rest of the time, it will not be, we cannot count on it. And that flexibility contract is only there for a few years. So in a sense, we have to switch from handling objects that are in our processes for the entire lifetime to some objects that have kind of a different life cycle. And that is quite of a challenge. And the final sixth work package is, of course, to do change management. It is a change for our business units, for our processes, like I said, but it's also a change for all our stakeholders, be it the TSO, be it the market players, be it also our customers, because that's the customers that are the source of flexibility. So they have to grasp how much money they can save with flexibility and what's the constraints, and be convinced that the balance is to go to flexibility so that they can save more money than the disadvantage they may get by being flexible. So that's basically our roadmap to industrialize flexibility. So within a few years, it's supposed to be, and we work so that it's a normal business in our company. So with that, I leave the floor to the next participant.
Thank you very much, Hubert Dupin, for this presentation, explaining us about how Enedis is dealing with the flexibility issue. So now we will have Energy Pool. So Energy Pool, you are an aggregator company, member of Smartgrids, and you are going to talk to us about Mr. Cantegrel. You are Senior VP Business and International Development at Energy Pool, and you will explain us how Energy Pool, what kind of solutions you are offering and what kind of experimentation and business as usual have you been doing already as for the flexibility solutions. Please, Mr. Cantegrel Emmanuel, the floor is yours. So
Thanks, Valériane. I suppose that everybody is listening to me. So thanks for this invitation, giving us the possibility to express and give you some examples for sure about what we are doing at Energy Pool. We decided to give you some views about two things. One is about what we do for utility at TEPCO level in Japan, and the second one, what we do in terms of support to industrial players. Do you see my screen well? Because I feel that it's quite in small size, no?
Yes, it is in small size.
Okay, let me adjust.
Maybe with the diaporama function.
Like this?
Switch to full screen.
Is it okay now?
It's a little bit better, but not yet.
Okay, let me check.
Oh, yes, now.
Okay, fine. So just to give you in a few words about Energy Pool, we are one of the leading aggregator and flexibility player in the world, which is not the most easy. The most difficult is to remain one of the leading players. So we continue to increase our activities all across the world. I'll say a word about that in a few minutes. We have been set up in 2009, and we have a strong DNA towards heavy industry activity. This was the reason of the creation of Energy Pool, identifying already in 2009 the potential of flexibility for heavy industry players. We are nearly 100 people all across the world with different operation centers depending on our activities, and we manage today a bit more than 1,000 sites.
Emmanuel, I'm sorry to interrupt, but we lost your presentation. You should share again your screen, please.
Okay. You tell me when okay.
Still not. Yes.
Yes.
Full,
Yeah.
yes.
Is it okay?
Perfect.
Okay, fine. Sorry for this disturbance. I move to the second slide, which is the presentation of what we do in terms of flexibility. We are in the middle, in fact, of the business between utilities and then the flexibility needs from system operators, centralized generation utilities, and renewable energy sources, and also in between the prosumers and the complex system approach, which includes for sure the end user demand response, but also battery storage and distributed energy resources. Energy pool provides the platform and the services plus the operations in order to perform those flexibility opportunities 24/7. To give you to enter into the example and before reaching the Japan territory, just to mention that most of the aggregators, not only Energy Pool, work with different type of industry in order to consolidate their pool of activity, and then also to consolidate the efficiency of the pool by itself in order to serve the grid requirements. So we work mostly with steel industry, aluminium plants also. I'll refer about that in a few slides, but also water treatment, chemical industry, cement, most of those being heavy players and that all across the dynamic countries for flexibility. We perform mostly, and this is again an example of what aggregators do. I believe that my colleagues also from other companies are doing the same with their different teams. We perform consulting activities for states or for countries or for authorities which want to implement flexibility programs. We for sure perform operations in different centers that we have all across the world. And the most important is the tool, the muscle that will drive those flexibility operations, meaning the technology with the DRMS platform on one side at the control center and connected to the grid, and what we call the Flexbox, which are installed at the industrial sites where we can perform the flexibility opportunity. Reaching examples, I will not detail all the slide because it would be too long. The most important figures are on the bottom right of the slide. Today we talk about since we started our cooperation with TEPCO in 2014 after the Fukushima nuclear incidents. So the main aim was to optimize the portfolio of consumers of TEPCO in order to align it for sure with the production and consumption. And what we can say today is that we have more than 300 sites which represent more than 500 megawatts of flexibility. We perform implicit and explicit activation. We are the first company to perform along with TEPCO and for TEPCO on their behalf the demand response stimulation and for as an example, but which is quite linked to the French actuality in terms of activation. We already perform 6 activations since 1st of January and until January 12th because of the climate constraints and the temperature situation that occurred in Japan in the last few days. This is one of the examples of what we do and the kind of support that we provide to utilities on the utility side, acting as their expert or as their DRMS or demand response brick. Another example which could be quite relevant to illustrate all what we are talking about this morning is that when we are on a site, especially a heavy industry site, how do we work and how do we position the flexibility and how we are able to generate value creation, not only for the grid, but also for the industrial plant that will perform those flexibility or put its assets available for that. I'll take the example of Aldel. Aldel produce high quality aluminum in Netherlands, in northern Netherlands, the production of 160 tons per year of primary and recycled aluminium with 150 megawatt consumption. It's a site of about 350 guys. And the interesting part, which I'll also refer in my conclusion, in fact, is that the main aim of Aldel to join the TenneT program for optimization and flexibility activation in Netherlands was to position that flexibility within their green plan. So we first followed a roadmap that we designed with them. The first one was to repurpose the plant and stabilizing the grid as per the recommendation and the requirements from TenneT authority. The second part was to engage CO2 reduction and consider some energy storage solution, which we already started. And later on, which is a more longer-term plan, CO2 capturing as a supply for sustainable bio-based products. With Aldel, what is interesting is that to perform all of that, and even if we would be part of a green plan, I refer to that, the most important was to absorb on their behalf or for them all pertaining to the flexibility, meaning what kind of contract will I sign with the authorities, what kind of financial matters do I have to handle, what kind of technical upgrade do I have to perform on my site, and how will I operate in order first to serve as per my engagement, and second, to serve without any trouble for my production and for my manufacturing plan. We designed that for Aldel in order to enable this new potential of megawatt flexibility and targeting the energy transition of Netherlands, of TenneT, but also of this industrial player. Again, I don't go into details. I'll let you read. The only thing I will mention about that is that there is also an interesting part on that flexibility approach, which is modernization of the plant. And when we talk about modernization of the plant, we talk also about investment. And what we think is quite interesting there is that besides the fact that the industrial plant will generate money by giving megawatts availability to the grid, it also helps to modernize and to create better competitivity for the asset, the production asset for the plant. And on that topic, we decided between Aldel and Energy Pool to align the investment purpose, and Energy Pool took part in the investment business plan, which very clearly means that part of the revenue that is generated by the flexibility will be affected to the capex reimbursement for modernization of the plant. And what was interesting for the management of Aldel and also for the financial partners of Aldel was that at the same time we have an interesting or an intellectual approach of the production plan, and in the same time we continue to work on the competitiveness and better productivity approach. This investment brick represents a large part of the project. The engineering part is also another one. Engineering meaning that everything we put on the paper we have now to consolidate and to finalize. And this was also done along with different departments of Aldel, and then reaching to operations with two program launch as of today, MFRDA and FCR, and later on AFR to happen in 2021. As a conclusion, what I would say is that we noticed from the last few months with all the team of Energy Pool that the flexibility takes part in green plans for industrial, but we also notice that it takes part for green plans for countries or for authorities. What we notice is that it plays a role in the Paris Agreement objective. It takes a role on the CO2 reduction or carbon neutral approach. And this is maybe a big trend that we need to follow. And then the French technology, not only Energy Pool, but all the company pertaining to flexibility can play a big role at international level. Thank you.
Thank you very much, Emmanuel, for this presentation about energy pool activities and solutions, which are really of great interest. So now I'm going to leave the word to Lina Ruiz, and to Marine Jost from ESPUL. So, Mrs. Ruiz, you are from the R&D direction at ENGIE, and you are going to present us the results of the demo project Re-Stable. Please, Mrs. Ruiz, the floor is yours. Sorry, maybe it's Mrs. Jost first. Go on. Thanks.
Yes. Yes. Good morning. I hope you see the screen, and I will do this. Okay.
The screen, but it's not in the full size.
Is it now?
No, it is not.
Okay. And here?
Not yet.
Not yet.
Maybe go to the diaporama section.
Yeah, well, this is what I'm doing.
On the right part of your screen.
Yeah. Is this working now?
Still not, but please go on, go ahead.
Okay, so hi, thank you for having us. So indeed, there will be a two-person presentation. So I'm Marine Jost. I'm working for the association ESPUL, which is a pioneer in photovoltaics, and we have these two projects, Re-Stable and Regions, to present very briefly to you. They are AeroNet Smart Grid Energy System projects, and they therefore are European projects, but are financed by national energy agencies. And I will try to.
Marina, don't worry.
Yes.
Melinda will try to put the presentation from her own bureau.
Yeah, I'll try that.
So please go on.
Okay, therefore, so these two projects aim really at demonstrating that renewables energies can provide ancillary services via a virtual power plant, ancillary services that are essential for the security and quality of the energy, the electric system, and which will become very important when we have high penetration of renewables, up to 100% in 2050. In the Re-Stable, so I don't know if you were able to share the screen or, okay, perfect, thank you. Okay, you can go to the next one, please. Yes, and therefore in the Re-Stable, we are working with a virtual plant operator, which is the Research Institute Fraunhofer IEE, which has implemented this virtual power plant, which connects to plants via either the manufacturer's service, which, for example, is here Enercon, or directly to the producer central control, which then connects to its own plants, or directly attacking the SCADA system of individual plants. In order to provide here primary and secondary reserve, we have high requirements on control and monitoring, since these are very reactive services, and therefore we do monitoring at a 3-second time step at the power plant level, and these data are communicated in real time to the VPP. As well, a specificity of this project is to be able to compute an available active power at the plant site, because again, this has to be computed every 3 seconds. It's a reference of production, which is essentially what the plant is able to provide, depending on the weather and on plant characteristics, and absolutely independent from what the plant is actually producing. So it's a reference that can be used for measuring if the plant is really implementing the services it's asked to. And in terms of control, the same 3-second set points can be sent, and the reactions that are asked are very, very fast and to be compatible to with primary reserve. You can go to the next slide, please. Okay, and here we see an example, so to go in the concrete stuff. So this was a test made in Restable. It's a pool of 74 megawatts. 5 wind power plants are involved. And on the top of the image, you can see that this is the provision that is asked to the plants. So plus or minus 10 megawatts. And this is the requirements shown are for FCR, so frequency containment reserve, primary reserve, which where you see that the green band is the tolerance margin. And on the bottom, you can see that what we have done in order to show that the plants are able to provide as well positive as negative reserve is to pre-curtail the plants. And so let's say the blue is what the plant is producing. And we see that it's going down by 10 megawatts from its possibility of production, and then goes up in order to provide a positive reserve, goes down again to a schedule, and then goes down to provide a negative reserve. And so this implementation is based on an emulated frequency signal, which is used to demonstrate that the plants in Germany can provide a primary reserve. So in this project, we've shown that a pool of energy renewable plants without storage can provide very high quality services. And we've calculated for that KPIs, key performance indicators, as for FCR, but as well AFR, MFRR, which have all different reaction times and tolerance bandwidth. And therefore, I will let the floor now to Lina to present the part on the tertiary reserve. Thank you.
Okay, thank you, Karina. Okay, good morning, everyone. I just put on my camera. Okay. Okay, thank you. So good morning. Let me start by introducing myself. So my name is Lina Ruiz. I'm currently in charge of smart grid activities at ENGIE Green, and we are involved in a lot of projects focused on seeking to enhance flexibility from resources from renewable energy sources. So in my presentation, I aim to show you a real example on flexibility tested during the Restable project. In a particular work package number 3, focused on replacement services. Replacement reserves. So it's now in France of mechanism of adjustment. So in France, as you know, probably renewable power plants are not obliged to participate to the grid balancing. So my point here in this part is that we took part during a short period at the beginning in 2019 in the replacement reserve market. So it was the first time in France. So what did we do during this demonstration? So first of all, we have created an adjustment entity registered with RTE under code name Restate1. Indeed, Hydronex was the aggregator for this demonstration because Hydronex was the aggregator for the demonstration for the virtual power plant in different terms. And Restate1 was offered to RTE adjustment mechanism from the 25th February 2019 to the 3rd of March. So next slide, please. And let's move on the activation requested by RTE. So we go back in the past, and on Wednesday, 27 February, the forecast of Tordes 28 showed better level of expected production. So it was a fair chance to receive activation from the TSO. So if my memory is good, I remember on 28 February, about 4 p.m., we concluded a bid price adjustment, and in the evening, we received 2 subsequent activation. So the first activation on the left, it was a request to 0 megawatt load during 15 minutes from 7:45 p.m. to 8 p.m. And the second activation with the same request 1 hour later. So here we delivered a curtailment services in the balancing market. In next slide, please, I would like to illustrate in more detail. Please, next one. So I would like to illustrate it here in more detail activation number 1. So first that all, I need to explain that the assessment on the activation is made after the market rules. So it consists in computing, when the activation is 1, 3 main parameters. So requested volume, realized volume, error volume. Based on 10-minute production data and for each 30-minute interval. So the activation is considered successful if the error volume is less than 20% of requested volume, and realized volume is paid to the operator at bid price. Otherwise, the activation is failed and penalty needs to be paid to the operator to the grid according again to market rules. So if we check the bar graph, and we start to analyze the first time interval. So here in the first one, we are out of activation window. In the second 10-minute interval, activation starts at 7:45 p.m. So in the first 5-minute interval, actual production exceeds forecasted. And in the second one turbine couldn't be curtailed because we had some problems with the parameter configuration on the SCADA. So here we consider that the test was failed. In the last 10-minute interval, activation stopped at 8 p.m. The one turbine could not be curtailed, but the actual production is still within tolerance margin. So we consider that the test was successful. So we have two main knowledge here. So the first one is that the control on 10-minute production curve doesn't show the relevant output when activation starts or stops in the middle of the sham, as you can see on the bar graph. And activation also, the second point, is based on production forecast communicated by the RTE, but we consider that the system should allow frequent updates. So that's all for the demonstration, and I would like to conclude the Restable project with some conclusions. So first that all renewable energy sources can provide efficiently services for FCR and FRR. As showed by Marina in the previous presentation. Also, another point is that technical and regulatory rules applicable for resource will need to be adapted to the case of variable renewable energy sources like response time, asymmetric offers, and something like that. An important technical issue is about energy settlement, because the production program, as you know, from renewable energy sources can be hard to be defined in advance. So we can consider methods based on site resource metering, like wind and irradiance, by using the concept of available active power that it was showed before. Just to finish, I would like to say a few words about the Regions project in this slide. So we started the Region project last year. Three European countries are involved, 14 partners. And the Regions project, in the opposite to the Restable project, aim to promote the participation of renewable production assets connected to the distribution level in order to provide flexibility service to the TSO. So in particular for us and for the French demonstrator for voltage support and congestion management. All services will be provided by the virtual power plant. So that's what we want to do in the French demonstrator, and we don't consider flexibility services to the DSO. We have a second demonstrator here, which is the German demonstration. And here in the German demonstrator, we would like to study and to resolve conflicts between congestion management and balancing services and the coordination at the European level. So at the moment, we have not results. We are just settling use cases with different partners involved in the project, and the demonstration will start in March or April, if my memory is good. We will be glad to present future results on the test in coming months. Thank you very much for your attention.
Thank you, Mrs. Rees and Ms. Jos, for your presentation about the Restable project. So now we are arriving now to the end of our webinar, and that's why I will now leave the floor to Yannick Jacquemart. Yannick, you are power system. You are power system economics director, and yes, you are leading all the issues related to the flexibility at RTE. So you are going to give us some words of conclusion, and I hope we can take some questions for the people who can still stay with us today. Please, Yannick, you have 5 minutes.
Thank you, Valeriane. Very difficult, tough, of course, to conclude on such a webinar with short, very complete, pretty much information and short presentations. What I will try to summarize maybe is the fact that, as Charles Verhaeg said, the flexibilities are used in the power system, especially in France, for decades. It doesn't prevent us from, of course, improving and getting more new technologies in the flexibility services and develop the range of services that the flexibilities can provide. I pretty much like, of course, the approach from my colleague, Mr. Dupin from Enedis, who said that our job, and I take it for us also, is to make the flexibilities part of our daily business and have them entering all our work streams or industrial parts. I used to say it for RTE, the TSO, that we need to be fully flexibility ready. And what I mean by this is that it was not the case this morning, but there is quite often a big debate about the needs of the power system with the energy transition and flexibilities, and they are sometimes estimated as huge. And I must say, our feeling in RTE is that it really depends on the time scale. After 2030, the system will be pretty much different. And of course, we will come to kind of generalization of what is happening now, which is we do not have to serve only the consumption, but we have to serve something like the residual consumption, which is consumption minus the renewable energy. And it creates some pretty different curve and pretty different paradigm in the way of dealing with this. And we will need more flexibility, of course, and flexibility on the demand side. We will have less maybe levers on the generation, but we may have pretty much more on the consumption. And of course, in between, there is the storage possibilities, which are increasing. For the moment, the needs did not change so much, in my opinion, and from the reports and the desk analysis, I mean for the French system for the moment. But there are new technologies, there are new schemes, and we know they will come into play and they will find their place. So we need to adapt, and this is what we are doing within RTE as well as within Enedis. We are adapting our mechanisms, market mechanisms, and now we come to the congestion of the network issue, which is different, and we will come to experiments after the destiny. We now come to experiments, and we saw in many presentations and also in the chat many discussions about the need for coordination between the TSO and DSO, and of course as member of ENSOE, I perfectly know, this is a huge debate at European level, but it needs also to be better appraised at the national level, and we have quite extensive discussions with NADs, but also with other distributing companies in the way to do this. We have experiments on the field, and this is now, I think, the new frontier, which is to coordinate between our mechanisms and to get the full range of mechanisms to have flexibility in them. But I must say, in France, in my opinion, it is already quite advanced. What is important to say is that since we are under the umbrella of Smartgrids and the CIRED, in the last decades, of course, many experiments have been done on smart grids, possibilities, and development of technologies and showcases and so on. And I think we are now quite aware that from the technology point of view, many things can be done. And what we are seeking sometimes are the business cases, and especially in the French system, which is hopefully rather robust, it is not always obvious. Whereas, since we speak from Smartgrids, I must say that all the expertise that we have seen, expertise from the system operators, I hope, but also from all the actors and universities and all the speakers today, have shown very good expertise and already track records on these fields. And I must say that this can be used also in other countries to set maybe experiments where the business case are more favorable. And it's very impressive to see that from the different kind of actors, we have the full ecosystem there. So this is maybe the main conclusion I want to draw. I think we are all very committed in following and reassessing regularly the business cases, the interest of developing new flexibilities in different services. It's an ongoing process. We will come to a more holistic view, I think, with the coordination of national European markets with more local issues like congestion management and more coordination between the constraints of the distributor, needs for the full system, and so on. I think this is what is going to happen and what is going to be best improved in the very next year. Thank you.
Thank you very much, Yannick. You are from RTE, so the French TSO, which is a monopoly in France. And now I really hope some of you can still stay for the very interesting answers we are going to give to the questions. So François, I think you've been collecting the different questions, and you can ask them directly to the speakers and maybe putting some together. François?
Yes. Do you hear me?
Yes, we do.
Okay, thank you. I shall, because the time is over, go to the answers for questions which were not answered during this presentation. The first one was from Colette Levinaire about different regulations regarding battery usages for TSO and DSO. Maybe Charles Verret could answer on this point.
Yes, sure. I can provide an answer. So I think the first issue is regarding the possibility for TSOs and DSOs to own batteries for their own purposes. So what I explained before, because I saw the question actually, is that in European law now, the default situation is that TSOs and DSOs cannot own batteries and use batteries for their own purposes, and obviously they cannot use batteries in order to participate in markets and do arbitrage and so on. There are some possibilities to derogate from this default situation especially when we can identify some kind of market failures, which means that in practice, if the TSOs or the DSOs do not build these batteries, they won't be able to use such flexibility, and therefore they will have to resort to less efficient approaches. So this is somehow what we've done through when we allowed the Ringo project, even though the regulation was not already in place. But the idea was just to make the experiment possible without having to wait for a market development of batteries in France, also not knowing exactly where these batteries should be located. So I think that's the first step. The second step is regarding how TSOs and DSOs can use these batteries for their own purposes. Once we've agreed that they should contract with third parties, the exact framework for that is being developed. The idea at this stage is to try and experiment how this battery can be used by TSOs and DSOs through the Ringo project, through the project, the experimental project explained by Nedis also before. And we're also discussing the regulatory and market design framework within the different consultation groups organized by RT, in order to gradually implement a framework which will be efficient and adequate for battery owners to be able to provide their services to TSOs and DSOs.
Thank you. The second question, which was not answered, is Marc Boileau's one. I am interested with the value of flexibility on different markets. And I think Alain Malo could give some short answer on this point.
Well, I'm afraid there are no publicly available reports on the value of flexibility. What I would say is that it highly depends on markets and copper plates. In fact, what we see from the UK is totally different to what we see in France, for instance, because the constraints on the existing systems are totally different. So there is no digest on those, but there are price points mentioned by some reports on some use cases in some countries which are somewhat available. But having a global picture on the value streams and the real quantification is a big difficulty that we are all facing. And I mentioned about this blog of Monde de l'Énergie saying that there are high expectations on the value of flex growing, but this is not being materialized in a worldwide consolidation of things.
Okay, thank you. There were afterwards questions about separate flexibility, market design, and so on, which were answered, and also about Smart Map 2020, which were also answered. And I propose you to come to the question of Jenny Marcos about system stability and improvement in system stability with coordination and also flexibility. Maybe Alain, you could try to answer, please.
I would say this is rather a TSO specialty. What I would say is the stability is affected with a very high level of renewable penetration in some places already. So I'm talking about UK with the ongoing effort on offshore wind, typically in Australia and California. And in those places, they are facing a new thing which we don't have in France, which is called inertia. And I could see a lot of discussions on inertial problems initiated by Marine and with lots of contributors viewing at the Migrate projects, which aims at running power systems with a very high level of renewables. So this challenge is not present in France at this point in time, since we are connected to the EU interconnected copper plate, so we benefit from the stability from our neighbors. But in non-interconnected copper plates like UK, this is getting a real traction, and there is a big difficulty to handle the inertia problem, and so looking at redefining the frequency services with enhanced frequency services to handle the complexity of the future system stability.
Thank you, Alain. Afterwards, we got questions with answers about ENEDIS and regional activities. We got also questions about frequency stability, and it was also a matter of discussion between Jean-Pierre Chevalier, Marignos, Jean-François Tissier, and I think we have a last discussion, which is also wished by Marignos with Alain, and I think it could be done directly. So
we know each other.
Okay.
So,
Yes, we'll take in touch.
It's all, and I thank you very much for your attention, and I give back the floor to Valériane.
thank you very much, François. So I just need now to thank all our participants and especially those ones who have been staying here with us till this time. And as said before, we will provide you the recording of the webinar as well as the slides. Thank you for your attention. Thank you for your very good questions. And thank you to all our speakers for their different insights, which were very interesting for all of us. A special thank also to Noureddin Al-Said, who is the president of the Scientific Council of Smartgrids. I wish you a very good day, good morning or good afternoon regarding the places where you are. And yes, and be safe. Bye-bye. Thank you.
Thank you very much. Have a good day. Bye.
Bye.